Recirculation aquaculture systems. So in the word itself it have a meaning. So water is recirculation within our culture system. So definitely we need some kind of a treatment. So there are different scales of treatments. So basic idea is water recirculation through the system in this kind of aquaculture systems, right? So you already know flow through systems, water flowing through the system, so that is one type, and water recirculation through the system, this is another type, right? So major concern in this recirculation, so we are recirculation the used water, right? So definitely we need to deal with the water quality parameters, and if most of the time we need the treatment process in middle of this recirculation the process. Okay, let's move to the slides. And so what is RAs, recirculation aquaculture systems? So this is actually we are reusing water in this recirculation aquaculture systems, water many times, passing the water through the treatment process. So in here water passing through the this treatment process to remove waste and restore water quality, right? So in this recirculation system the water is passing through this treatment process and removing the waste. If it is a solid waste, there are solid waste removing filters. If it is liquid waste, there's another things, and the so number of treatment process applicable, and we'll discuss what are the treatment process applicable in this recirculation system commonly. And RAS offers the advantage that temperature and other variables can be controlled in order to maximize the growth and maintenance of fish health, right? So minimizing the discharge to the environment and allowing operations to be established even where water supply is quite small. So sometimes water supply is limited factor in our farming practices. So then this recirculation aquaculture system is the best solution. So you know in the flow through system it is for an example in the raceways there are available water is there, so water flowing through every time. So but in the when you have limited amount of water supply or the small amount of water supply, so we can definitely go with this recirculation aquaculture system with proper treatment process. Okay, I think the what is about this recirculation aquaculture process, you got the point. So this is a diagram for this recirculation aquaculture systems and the flow through systems. So this is the flow through system. Water is flowing through the tank and it's not coming back. So recirculation aquaculture systems, water coming to the fish tanks and water outlet is there. So we are pumping water again, and water goes through the treatment plants or the treatment filtration tanks, and it comes again to the water inlet and goes through the fish tank. So we have different degrees of this water circulation. So sometimes we are getting 100% of water through the pump, sometimes not, we are getting less percentages. So it's highly depend on our activities, our scale and the things. So reuse, recycling, or the water recirculation. So this is the simplest process. We are taking water from the inlet and water going through the outlet. While going through the outlet, we are pumping water again to the water treatment plants, and it comes to the water inlet again. So this is the basic steps in the this water recirculation aquaculture systems, or the reusing aquaculture systems, right? So in this diagram you can see the simplified process of flow diagram, how this recirculation aquaculture system is working. So this organized set of complementary process that allow the least portion of the water leaving. So least a portion of the water, right? Sometimes not 100% coming to the tank. So it's a portion of the water is leaving from the tank, and just portion of the water coming to the coming through the pumps and the filtration. So fish to a fish culture tank to be reconditioned and then reused. So same fish culture tanks or other fish culture tanks. so we can recirculate. So usually we are in our farms, so there is not only one tank or the one pond, so there is a culture systems, number of ponds are there. So sometimes water going out from this one tank and comes to the another tank from the filtration process, so it goes to same fish culture tank, right, or the other fish culture tanks. So don't get the idea, so it comes to the same tank again. So sometimes it can goes for other tanks, so it goes through this filtration process, right? So in this diagram also you can see so there's a grow out tank, in there are large culture tanks where the fish or the shellfish are raised, right? Grow out tanks were there, so fish waste and the uneaten feeds were there in the water, so recirculation water goes out from these tanks, and first step is a solid removals. So in the solid removals, such fecal materials, uneaten foods removed by the mechanical filters, right? So there are several types of filters we are using the mechanical filters. We are removing these uh, fecal materials and the uneaten foods, cull of the species sometimes, right? So using mechanical filters, we are removing these solids. Solid removal is the first step in the filtration system. So then we are coming for the biofiltration. So in here we are going to remove the ammonia removal is done here. So beneficial bacteria uh, consumes ammonia, which converted into nitrogen and release uh, into the atmosphere. So after solid removal we are coming for the biofiltration. So then we are going for the oxygenation. So in each and every steps we need to carefully deal with these water quality parameters. So as the final step of this flow recirculation system, in the filtration system we are going to the oxygenation process. Okay, so re-oxygenated water then again return into the this tank, sometimes other tanks which in the same condition. So basic idea about recirculation. So this is the simple process of recirculation. Water is reusing with reconditioning or the filtration. Okay, so in recirculation aquaculture system it is necessary to treat the water continuously. So water need to treat continuously, because if the water removing from the tank continuously, then we need to treat the water continuously to remove the waste products excreted by the fish and add oxygen to keep the fish alive. So from the outlet of the fish tanks, the water flows the mechanical filters as we discussed earlier, and further it goes for the biological filters, and it is before it is aerated, stripped to the carbon dioxide and returned to the fish tank. So several other facilities can be added. So these are the basic steps, right? So we can add several other facilities can be such as oxygenation, as we discussed in the previous diagram, with pure oxygen or UV lights also, on ozone disinfections, automatic pH regulations, heat exchanging and disinfection systems. So this is highly depending on the exact requirement and the scale of our tanks. So quality of the water in the outlet and quality of the water we need in the inlets. So these things highly depends on this exact requirement. So now you have a good idea about what is this recirculation aquaculture systems and what are the components of this recirculation aquaculture systems, right? Okay, so this is very good method. So you can see this is sustainability is there. So water is recirculation through the filters and we are reusing the water. Infinity expandability is there. So with the improving of our filtration system, we can expand the system, and this is environmentally compatible system. So has the ability to guarantee both the safety and the quality of the fish produced throughout the year. So if we can if we have the water throughout the year, because water is recirculation in this system, so and also raising fish in the controlled environment, permitting controlled product growth rates and predictable harvesting schedule. So as we discussed in the previous point, this is throughout the year we can do this kind of activities, and raising fish in the controlled environment. So this environment is controlling because water quality and the parameters are we are controlling, and so the growth rates and the predictable harvesting can be scheduled. So conserve heat and water through water reuse, so not like in the flowing through in sometimes. So in here we are reusing the water. Okay, let's move in with the slides. And the water treatment process are used to change the characters of water passed through the process, right? Sometimes water treatment process can be changed more than one characteristics of the water. For an example, water flowing through a trickling biofilter can gain dissolved oxygen and nitrate, while dissolved carbon dioxide and unionized ammonia are removed. So degrees of this water circulation is the main thing that we are dividing this, how this water recirculation happen in this water recirculation system. Reusing, we can say the degree of water circulation, right? So depends upon the water use, intensity and species specific water quality requirements. So basically we are talking about what is the portion of water taking to recirculation by these degrees of water recirculation. Okay, so we are going for this degree of recirculation. So this is actually calculation of the degree. So simple idea is which portion goes through the filtration after outlet. So not 100%, sometimes which percentage goes. So in this example you can see that so describe so we are using this degree of recirculation thing to describe the reuse, right? To describe the reuse or recycling system, several parameters are required, right? So degree of reuse, so this is one parameter, right? Give the percentage of the new incoming water in relation to the total amount of water. So in this system, so as we talked earlier, so water comes in, water goes out. So when water going out, some amount of water comes again and goes through this filtration system and comes to the inlet, right? So this some amount of water is releasing, so we need to fill that gap. To fill that gap we need to input some percentage of water, right? So that percentage is the new incoming water, this Qn, in relation to the total amount of water flowing into the fish tank. So in this degree of reuse we are calculating new incoming water as a percentage to the total water goes through the this fish tank. Okay, I think you got the point, right? So this is the equation, R equals 1 minus Qn divided by Q total as a percentage we are going to say. So in here degree of reuse, so Qn is the new incoming water, Qt is the total water supply to the fish tank. It means the new incoming water plus reused water, right? So total water quantity comes with new incoming water and the reused water. Qn is the new incoming water. So this is example. If the supply of new water to a farm is 150 liter per minute and the total water flow is 1000 liter per minute. Okay, so calculate the degree of reuse. So then the degree of reuse is 1 minus Qn divided by Q2 multiply by 100 for the percentage. So 1 minus, so this is the calculation, so you can get the 85%. So the degree of reuse is 85%. So this is one way of describing our recirculation system, right? So we can say we have a recirculation aquaculture system which in the system the degree of reuse is 85%. So degree of reusing water capability is 85%, right? So I think you got the idea about this recirculation aquaculture systems explanation with the degree of reuse. But the degree of reuse does not give enough information about the performances of this system. It's not sufficient to describe the recirculation aquaculture system properly. The thing is, in here we are talking about only a water input, right? Which amount of water comes through the system, or which amount of water goes out to the system. So that's the idea we are getting from this kind of calculation. But we are not getting the idea about which amount of new water added per kilogram of fish, which amount of water added to the based on the number of species available in our system. It means the number of kilograms. If we can say for kilogram of fish this number of liters are input or the go through the our reusing through our system, then that will give a proper idea about our recirculation aquaculture systems. So again this recirculation like degree of reuse also give a good idea. But if you can tell more about the kilograms per kilogram of species, this amount of water comes through the system and going to be used, like things that will give you more idea, more uh, understanding about our recirculation aquaculture system, right? Okay, so then we are moving for the second equation or the second way of describing our recirculation aquaculture system. It means the degree of purification. So how effectively the cleaning plant in the reuse circuit removes unwanted substances. So this is basically we are talking about the effectiveness of our filtration system. So where CP equals C in minus C out divided by C in, it also comes as the percentage, right? Okay, Cp equals degree of purification. That's what we are calculating here. It means the how effectively the cleaning plant in the reuse circuit removes unwanted substances. So in here we are talking about the concentration, right? So concentration of the actual substances entering the cleaning unit. So this is C in means the concentration of the actual substances entering to the cleaning unit, and this is the concentration of the actual substances leaving the cleaning unit. So we can get the percentage of degree of purification. It means the how effectively the cleaning plant in the reuse circuits removes unwanted materials, right? So we are concentration of the inlet materials minus by concentration of the outlet materials and divided by the inlet materials and giving the percentage of the degree of purification. So this is another way that we can tell about our recirculation aquaculture system. So degree of purification of our recirculation aquaculture system is around 75%. So we can tell like that. Okay. Okay, so this is another way, the mass flow of the system. So we can say concentration of substances at different stages. So concentration of the substances, in the previous slide we talked the concentration of the substances in the inlet and the outlet. Then we are dividing and we are taking the idea about which amount of concentration removing from our filtration systems. So in here we are talking about the concentration of the substances at different stages in the system. Also important to get the clear picture, right? C equals M divided by Q. So the Q is the water flow liter per minute, M is the mass flow of the substances, milligram per minute, and the concentration of the substances milligram per liter, right? Okay, so where so this is the equation. So in this diagram you can see, okay, so in here new water is coming, so we have qi ci mi and outlet. So from the production unit it goes out qo co and the mo outlet. So again this is recirculation and goes through the water treatment unit, and so mass flow of substances, some substances, debris, materials goes out from the filters, right? Again this is come to the inlet. Okay, so while calculating this kind of mass flow, again we can get the idea about concentration in the different stages, right? So using that also we can describe our recirculation aquaculture systems. We having this kind of mass removing, we have this kind of concentration in the inlets, this kind of concentration when we passing through the water treatment units. So we are looking at each and is these points to describe our recirculation system, right? Okay, so based on the intensity of the culture we can decide what is the degree of recirculation that we needed. So in the previously we are calculating the degree of recirculation and the several calculation, mass flow and the concentrations. So all these calculations and the things we discussed to give a proper idea to our recirculation system. So our recirculation system need to be this 85% purity water new water in intake comes to the system, or the 5% new water comes to the system likewise. So get the proper idea about what kind of system we needed. We discussed previous three calculations, right? So based on those things, based on the intensity of our culture system, we can decide which kind of degree of recirculation we needed. So it's based on the our culture species, our production, stocking densities, and the intensity, especially the all comes to the end as a intensity. So if it is intensive farming we are doing, or the semi-intensive, so then we can think about the number of filters we need to use, or the degree of recirculation we need to deal with, right? Okay. Okay, so these diagrams of plants suitable for different degrees of water recirculation as we discussed earlier. So this kind of so we can see how this degree of water recirculation. So in here no reuse, aeration, oxygenation, or the fish tanks, water comes from the inlet and goes from the outlet. And the lowest degree of recirculation, only aeration and oxygenation is there. Okay, so in here particle removal is there, like solid removal. In here ammonia removal is there, and here like pH regulations, disinfections, all the aeration and oxygenation is there, and the particle removal is there, ammonia removal is there. So this is highly dependent on our practices, our intensity of our farming. So we can decide which scale of filtration system we need for our reusing water reuse or water recirculation aquaculture system, right? Okay, so recirculation aquaculture system actually call for the new skills for our aquaculture sector. So at earlier aquaculture is for the everyone can do kind of a seed production and putting in the some kind of open area in the water, or the cage, simple cage, and do the practice. Still they can practice this kind of care. But if you need to earn more with this, own more profit or maximize your scale of business, you need to move this kind of recirculation aquaculture systems. So it means the advanced systems in recirculation aquaculture systems. So using of the new water is the minimal, you are using same water recirculation through the systems, right? But do these things, you need some such knowledge about recirculation aquaculture system. So aquaculture is not for everyone. It required knowledge, good husbandry and persistence. So shifting from the traditional fish farming into recirculation does make many things easier. However, at the same time it requires new and greater skills and knowledge, right? So then we are going to talk about the components of recirculation aquaculture systems. Okay, so definitely now you know the components. Actually there's a fish tank is there, water inlet is there, outlet is there, pumps were there, and the components of the filtration systems and solid removal filtrations were there, oxygenation, aerations, things were there, right? Okay, so then this RA's components, basically we have this number of components. So fish tanks or the units of aquaculture species, and the water treatment system, pumps to transport the water around the systems, and other accessories uh, like UV filters, sometimes like things we can use. Okay, so as a tanks, I'm not going to talk much about the tanks because you know, so in every subject, most of the time in the advanced techniques, in the cage culture or whatever the things we are talking, pond construction or the tank construction, we are talking the shapes of these cages, tanks, and also you know what is the basic of tanks. So, and there are several shapes, several materials we are using. What are the parameters we need to consider of selecting the material, and the durability of this material should be there. So I'm go through quickly. So tank shape and size are adapted to the desired fish species and the size, and as materials fiberglass, steel, concrete, plastic, glass, and other with the liners we can use, and the non-toxic material we needed. Durability is high concerning. Good hydraulic characteristics need to be present. Okay, promote mixing of and the solid removals. So tanks can be characterized by the diameter or depth or the ratio per diameter per depth, right? So this ratio should be maintained greater than 3, less than 10, and preferably less than 5. Okay, so tanks can be characterized by the diameter to depth ratio, right? Tanks can be characterized by the diameter to depth ratio. This preferable ratio is 5, so need to be greater than 3 and less than 10. Okay, so that's so when it comes to tank, outlets must be constructed for optimal removal of the waste particles and fitted with the screens with suitable mesh sizes. So when water goes through outlets, we can make these particle removal nets and all, so solid removal nets. And tanks can be fitted with the water levels, alarms, oxygen probes for the oxygen control, and the alarms and emergency oxygen diffusions. So tanks can be fitted with the water level alarms, so we can fix water level alarms if the water level is exceeding or goes out for minimized for the several levels, so we can deal with so they are alarming for us. Even nowadays we can use several sensors, and simply they are sending the message for our mobile phone, like mobile applications, or some things we can use for that. So we can use oxygen probes. So there are number of sensors, DO sensors, and also we can use these things in these cases. uh, yes, okay, so that's about the tanks. And one of the most important rules for this recirculation aquaculture system is that solids needs to be removed from the tank as quickly and efficiently as possible to reduce the solid impact on the water quality. So if the solid are present more time in the water, so then the water quality is damaging more. So then we need to deal about more filtration and the aeration and oxygenation like things. So okay, so the major thing is removed from the tank. The solids need to remove from the tank very quickly and efficiently. And using this range of this depth to ratio will minimize the problems of solid settling, right? So that's why in the previous slide we defined the ratio as the around 5 may be very preferable, right? Okay, so water treatment in recirculation aquaculture system, there are four major water treatment variables in recirculation aquaculture system. Okay, oxygen, ammonia, carbon dioxide, and the solid waste. So those are the major types of waste treatments we are going to deal in this recirculation aquaculture systems, right? So water EU system generally required at least one or more of following treatment processes, right? So in here we are going to talk about the treatment processes. So sedimentation unit should be there, and the granular filters or the mechanical filters to reduce the particulate solids. So solid removal part is there, and biological filters to decrease the dissolved waste. And we need biological filters to decrease the dissolved waste in the outlet, and aerators to add dissolved oxygen and decrease dissolved carbon dioxide or nitrogen gas to levels closer to the atmospheric saturations, right? And also the oxygenation units to increase the dissolved oxygen concentrations above atmospheric saturation levels, right? So advanced oxygen units, it means the UV filters or units at ozones to disinfect oxidized organic waste and nitrates or supplement effectiveness of the other waste treatment units. Finally, we can deal with these pH controllers to add alkaline chemicals for maintaining water buffering or the pH levels in stable line and reducing dissolved carbon dioxide levels. And also heaters or the chillers bring water temperature. So we are putting these sensors here, temperature sensors, DO sensors. So in your mini project subject also you deal with these kind of, some groups dealing with these kind of automated systems. So likewise we can use these kind of sensors for these systems. Actually they are using these sensors nowadays. So it simply gives us the updated meantime values, real-time values of these things. So so in our system it sometimes it present everything, sometimes it present some of these parts. Generally these are the required things for the treatment process, right? Okay, so finally so this is the basic steps of the fish tank. It comes to feed and the species were there, and inlet water, it outlet water goes to the mechanical filters. Okay, so then disinfection is happening and wastewater goes out and the water comes to the system, and from the pumps it comes to the biological filters and go to the fish tank. So this is a simple diagram again. So now you have the idea what are the parts in this recirculation aquaculture systems, starting from the fish tanks, then water inlet, fish tanks, water outlets, and from the pumps it goes for the filtration system. Filtration system has several filters, mechanical filters, biological filters were there, and UV filters. Sometimes oxygenation aerations need to be done, and water comes again to the fish tank, right? So that's all about this recirculation aquaculture systems, and you have one assignment, and I'll upload this assignment and what you need to do to the VLD, so then you can have a better idea with this assignment. So you need to write a detailed account about this recirculation aquaculture system. In here we have discussed how to describe the recirculation aquaculture systems and what are the components of recirculation aquaculture systems, and if it is a filtration systems, what are the types of filters we are using for the filtration systems. As a pumps, what are the pumps we are using. So you need to write search and write a detailed account with references. So I'll upload you to VLE about this assignment. Okay, so that's all about recirculation aquaculture systems. I think you got a proper idea with this presentation. Thank you very much.